Welcome to the channel, guys. So today's video is going to be a Corvette related video, and we're going to be talking about the fuel system upgrade I did on my Corvette ZR1 recently. So I'm upgrading the fuel system because I plan on making over 900 wheel, maybe close to 1,000, maybe more, we'll see. So the car is running right now, and it sounds great. I can't believe how good the BTR Stage 4 cam sounds like on this car. I will post a video of that, of the startup on the base tune. So those of you guys who are interested, stay tuned for that. But let's talk about the fuel system upgrade on this car and what it took. So I did everything, okay? And it was not an easy process. You have to drop the tanks, both of them. It's quite the process. I'm lucky I didn't break any of the crossover tube or any of the evap lines or components. I did snap a couple of the evap clips. Those are easily replaceable and sourced. But it is a quite extensive process. I went with a Fore Innovations dual pump setup. So the primary pump is the TI-274 and the secondary pump is the TI-285. Which has about 10 to 15% more flow than the 274. So that will output 900 liters per hour. So that's good for 1400 wheel. I don't ever think I'm ever going to get that high, so I'm all set. Okay, so where I'm at. I wanted to build the fuel system as a good foundation on the car because I want to make some serious power. I want to be close to 1,000, if not past 1,000. With sufficient fuel and not stressing the fuel system out. So that's very important. And I wanted something that's reliable and well known. So Fore Innovations, I'm really happy with the quality of the fuel assembly or the fuel module, however you want to call it. It comes with its own controller, which is in the back. I'll show that in just a few minutes. But let's first go over the engine bay. Obviously, the lines come from the backside here, okay? So I'm going to try to illustrate this as best as I can. I put everything back together. So the driver's side tank, I have both lines, the feed and return, or send and return, whatever you want to call them. But there's two lines because this is a return style system. So the fuel will come out and then come back to the tank and circulate. So there's a lot of benefits to that. I'm not going to go over in this video. I'm just going to show the layout I have. So, okay, so the output is here. So two lines come out near the filler neck and go down the side of the car here in the rocker panel and then come up. And one comes up the top here. This is the send. So the send line goes across the back over to the other side of the engine bay. So it goes up underneath near the dry sump underneath this expansion tank here. So up, down, over again to this spot here, and right here I have a Fore Innovations check valve, which is necessary for this car. So as it makes its way around, it goes into a Injector Dynamics ID-F750 fuel filter with delta gauge, and it has this block here which is additional. This is a temperature and pressure gauge. So there's a Bosch sensor down low, if you can see that. Probably can't see it that great in the video, but I wired up this sensor versus the OEM. That way I can log the temperatures and the pressure through the dash logic. And well, the thing is I have the pressure going to the OEM wire, and then I have the fuel temperature going to the dash logic. So that has to be programmed in and formulated to read out correctly. But it comes out this Injector Dynamics filter, goes back around underneath the tank and up, and it goes along this line right here, which feeds the back side of the fuel rail. So I kind of did this backwards from what you normally see. Because the layout, I had to put this fuel filter here because of the generous amount of area here, and it barely clears the hood, which is great. So this spot ended up to work out just fine. You have to angle it so it's perfect and it meets the profile of the hood. I had to double check by viewing it with some grease. Put grease on here and closed the hood to make sure this spot was good. So a lot of time and effort went into fitting all these components into somewhere really that's not really designed for all this stuff. So out the fuel filter, across the top here on the firewall, into the rail, into the radium rails, and then across the front. So that did something different here most people don't do. So I came across the front to the other rail on the front side, to the rail, and then back out here to the fuel regulator, fuel pressure regulator. This is a radium setup, and it goes down to 90, and then it goes to the flex fuel sensor, which is right here, and then it goes down and then back out this way and back to the tank. So everything routes back to the tank. It's constantly circulating when you have the engine on or just a key on. So it's constantly circulating. And this here is the Hobbs switch. So I mounted it right here with a DMS block. And this is the Hobbs switch that goes for the secondary pump. So once this achieves 5 PSI, it will turn on that secondary pump. So that's how that works. I do have a mechanical gauge. Let me see if I can get a better shot of everything in here for you. So there is the fuel pressure regulator and fuel gauge. And then as you can see, flex fuel sensor, and then the output line, return line going back to the tank, to the pump. So it feeds down. Everything is wrapped in heat shield, as you can see. That way it mitigates the fuel being heated up by the engine heat. So eventually this thing's going to heat soak, and most people don't care, but I want to make a really crazy build, and I want to make sure I want to grab every kind of horsepower I can. So I wrapped all the fuel lines that you see here in the engine bay in the DEI heat sleeve. So this is high quality heat sleeve, and essentially it should keep the temperature of the fuel down, which is going to help with the charge temperature and cooling down your combustion chamber. So the cooler you can get that fuel, it all relates to more horsepower, whether it's 5 or 10, I don't know. We'll see. We'll see what the benefits are. So, but essentially, I have a good source to filter the fuel. This is all ethanol safe components. I used Vibrant fittings for Innovations fittings, as well as Vibrant Teflon braided lines. So everything I used is high quality. I didn't skimp out on anything. All these fittings here, I spent about $600-700 honestly on fittings. I'm not even kidding you, because I used all Vibrant high flow fittings, and whatever else that isn't Vibrant is Fore Innovations. So all these like spacers and these compact 90s that I needed to get this kind of transition and bend to work to the other side of the rail. As you can see, it clears the bypass valve actuator and mechanism perfectly. It took me a while to get this. I had to go back and forth with different types of, configuration and lines. I was thinking I had to bend a hard line, but I didn't like the look of that. So I ended up going with this look because I think it just looks awesome, and it serves a purpose here. It feeds the rail just like the way I want. Allows me to mount these components, in a better way, because otherwise, you're stuck with these. This is a pretty big component here, this fuel filter, and then you have the regulator with that whole setup with the flex fuel sensor. This stuff takes up a lot of space. So it took me about a month and a half to really figure out the routing of the lines. Like doing this off and on. I work full time, so I do this on my spare time, my personal time. And it still takes a long time because you have to piece things together, then figure out what components you need, then go order them, then try out the components, see if they work, and if they don't work, you have to start the whole process over again. But that is the fuel system. I want to do a video on the intercooler system, which obviously you don't see the lines here because I'm in the middle of finishing that up. I don't want to go into detail in this video because I want to kind of relate this to only the fuel system. But like I said, it will be logging the temperature. That's something new for me. So I want to log the temperature of the fuel. And essentially that's the reason why also I have all these lines insulated, because race cars do it. So if it's worth for race cars to do it, it's worth for me to do it. So that's the way I think about it. And there's a ton of heat, and circulating that fuel in an area that has a ton of heat like an oven, it's just going to make the fuel tank hot. It's going to warm up the fuel tank essentially by circulating through if you don't have insulated lines. So a lot of people just, they run the car without it. Of course it's going to be fine. It's going to make power no matter what. But I'm trying to pull every last bit of horsepower, and I think it's worth it. It's my time, so I'm not saying for you to do it. It's up to you. For me, I think it's worth it. So I spent the extra 3-4 hours and wrapped this painstakingly, inch by inch, and kind of fed it through. So some other things I want to touch on is I'm using Injector Dynamics 1300X fuel injectors. So the injectors are upgraded, and I think I covered everything. I mean, I'm using the FC3 controller for the fuel pump. So that's a Fore Innovations controller. So the wiring for that, so you have to wire up the Hobbs switch, which goes down the side here as well, and into the trunk. All right, so everything's kind of in its place now and put away, but I'm going to kind of illustrate you and maybe show you a picture on the screen of what it looks like, because I did take a picture when I had all the panels exposed here and the carpet out. But essentially, it comes in from this side. Okay, so right about here, through a grommet, all that wiring comes through here, goes along the back, and then I mounted the FC3 controller right here vertically, and then I routed the power lines through here and then down and attached them to the battery. Now the reason why I did that is because I didn't want all that extra heavy gauge copper wiring weighing down the car. So that's why I went with a lighter gauge, pump power wires all to here, and then from here the thicker, whatever they are, 6 gauge, they're huge. And it's heavy, so you don't want to be running a lot of heavy copper wire in here because it's just going to add weight to your car. So I only have about 3 feet of heavy gauge, 6 gauge copper wire going to, actually, it might even be 4 gauge, honestly. It's pretty thick stuff. But anyways, I wanted to minimize the weight, and I kind of wanted to shorten that length so it's right at the battery, getting a direct feed, and it's not too heavy. Same thing with the Hobbs switch. The Hobbs switch is wired all the way here, all wire loomed and neatly tucked away and zip tied, and that's attached to the FC3 controller. And right here, if you can see, is a fuel cutoff switch. That way, when I have the car keyed on and I don't want the fuel pump circulating, I can cut off the fuel pump and not have it just constantly draining the battery. Otherwise, when you have your key on, it's going to be constantly circulating. So if you're messing around with a laptop on HP tuners or doing something on the car where you're trying to figure out the dash logic or whatever. So that right there is a good kind of alternative to unplugging the pump every time from the FC3 controller, which will get very annoying because you have to, dismount all your carpet and everything and rip everything up. So that's why I put the switch there. It's just a really nice convenience, so I can turn the pumps off if I need to mess around with the car and I have to have the key on for whatever reason. So I will show a picture on the screen of what it looks like because I did take pictures for you guys, and that's the layout. I mean, it took quite the process and quite some time to get it all laid out and done. I think the fuel system was a huge project for this car. It took about a month and a half in itself. Dropping the tanks was not easy. It's not something you want to do all the time. So I'm glad I did it now. That way I have everything I need for the future if I plan on adding anything more to the car. So that's a quick breakdown of everything. I'll go over really quick, I think, this right here, which is a custom manifold I made for vacuum boost reference. This has a high boost, pneumatic line set up here going to the block, and then it has silicone low boost lines, you could call them, to the fuel pressure regulator. This fuel pressure regulator has a damper in it right here, so it has 2 lines. I cut up all the factory tubing and hose ends to reuse them for certain stuff. Nothing on here is factory. As you can tell, everything is routed differently. I had to redo all sorts of stuff, but I think this layout works great. I redid the fitting on the supercharger to a larger thread so I can get more vacuum. So it has a larger line going to the vacuum boost block, to feed all of this manifold here and all these lines. I want to increase the line size because that helps with operating the bypass valve actuator and referencing the fuel pressure regulator as well. So that's important to do. I upgraded all that. That was quite the project, but it came out great. So that's going to be it for this video. I will have a startup video, and once I finish the intercooler system, okay, as you can see there's no lines, I will make a video on my custom intercooler system, which has 2 pumps, 2 expansion tanks, and a custom L-Brock heat exchanger with dual ins and dual outs, all 3/4 line. So stay tuned for that. I'll make a video once I'm done. I'm almost done. I just have to plumb up the hose and do the final touches on that, and then I can get the car on the ground and running. So, and actually drive it and see if I need to touch up the bass tune. So that's going to be it for today, guys. I really hope you enjoy this video, and if you have any questions or comments, place them right down below, and like and subscribe if you haven't done so already. I want to thank you guys for watching, and I'll see you guys on the next video.